for us to present our project in the 53rd CII Convention, Kaizen Competition. So we are from TVS Sundaram Clayton Limited. Our Kaizen category is renovation category. The title is Reduce Leak Rejection in IS is Reduce Casting from 4.8% to less than 1.5%. The presenter myself Sriram from Quality Department.
Myself Suresh from Operation.
So this is our Sundaram Clayton overview. Our vision is to accelerate adoption of sustainable light alloy solution globally. So we are a 100-year tradition company. So we are successfully in the core business of commercial vehicles, passenger cars and two-wheelers, and we have entered into the EV and structural parts. So we have two plants located at Chennai. We are from Oragadam plant. Where casting and machining facilities are available. We are supplying for domestic and export customers. Our major customers are Hyundai, Kia, DAF and Daimler. So this is our overall part-wise rejection Pareto, where IS6 contributes 22% in overall rejection. We have done Jogari window, where the IS6 is the top tonnage part, where we are having highest rejection percentage, more than 7%. So this is the defect-based rejection Pareto, where the leak contributes 58% in overall IS6 part. The importance of problem is due to high rejection, rejection is not achieved as per plan. COPQ is 6.5 lakhs per annum. Customer demand can't achieve as per plan. The pipeline stock has been reduced to 12 weeks. So due to high rejection, we are producing Sunday production also. The product details of customer Cummins USA plant. Our annual volume is 35,000 shots. Part weight is 9.3 kg. The process is basically a gravity die casting process. So this is a leak rejection trend against a plan of 1.5%. Right now we are at 4.6% average. So we have used P-chart tool to confirm that the cost which you are taking is significant or not. So the P value found is 0.04. So which is a significant cost. Over to Suresh.
This is our observation. Process microprocess flow. The problem occur in zone certification stage. This is the location matrix. In bottom tie C4 location leak is contributed. In top tie F3 location contributed. This is our leak location 1 and location 2 leak video. We identified the leak through SOPAL test. Then is now leak not take apart. You checked a radiograph inspection. The level 5 sinkage observed against the spec level 2 sinkage. We found sinkage microstructure analysis. The casting. The defect is sinkage confirmed through microstructure analysis.
So we have used is not analysis, where we have compared within the part the defect location and good location. The rib thickness was found difference, but it is a part profile. So with respect to wall thickness, there is no major deviations. With respect to radius, there is no deviation. With respect to die temperature, there is a spike in defect location. So we were going for further analysis. So this is our location 1 analysis. Die temperature is high. So spec is 350 to 450 degrees Celsius. While running condition is